Hello class, today we're going to be learning about triangle essentials, some essential theorems that help you work with triangles every day in geometry. To start with, we're going to show you the Pythagorean theorem. It's one of the most important theorems in geometry because it's very useful. But one thing about it is that it only works on right triangles. A lot of people try to use it on all triangles, but it will only work for a right triangle, so remember that. The formula is simple. A squared plus b squared equals c squared. But what are a, b, and c? Well, in the next slide you'll find out. A, b, and c are sides of a right triangle. The shorter leg is a, the longer leg is b, and c is the hypotenuse. So if we square side a and add that to the square of side b, then the total will be equal to side c squared. To prove this concept and prove that the Pythagorean theorem works, we're going to use Bhaskara's proof. It uses this diagram. This square in the center here is equal to b minus a squared, because this side of the triangle is equal to b, and the side of the square is what's left over when we subtract a from b. Each of these triangles is equal to 1/2 AB because the formula for the area of a triangle is half the area of the rectangle that would be formed like this with two of the triangles. So this side's A, this side's B. So each of the triangles is 1/2 AB. That means that altogether they're 2AB. So here is some equations. The total area of all four triangles is 2AB. This square in the center is a minus b squared. The entire large square, because each side of it is equal to c, is c squared. The small square plus the triangles, which is equal to the area of c squared, is 2ab plus a minus b squared. We're going to simplify this down here. A minus b squared is basically equal to a minus b times a minus b. So we can use FOIL. First, outside, inside, last. And that gives us a squared minus ab minus ab. And that's really just minus 2ab. So we have a squared minus 2ab plus b squared. Let's not forget this plus 2ab that's from these triangles, because remember, this is only the area of this square. So we have 2ab, and you notice that there's 2ab and then minus 2ab. Well, those cancel each other out. So we're left with a squared plus b squared. And because a squared plus b squared is this square plus these triangles, and that's equal to c squared, we can say that a squared plus b squared equals c squared, proving the Pythagorean theorem. So for some example problems. The Pythagorean theorem is commonly used to find the length of a missing side of a triangle. Given that this side is equal to 1 and this side is 9, it's pretty easy to find this hypotenuse here. We simply have to square this side and add that to the square of this side, and then this side, side C, will be equal to the square root of those two added together. So 1 squared is 1, 9 squared is 81. So 1 plus 81, 82. That means C is equal to square root of 82. Now here's another application of the Pythagorean theorem. We're going to use it to find the diagonal distance between these 2 points, from here down to here. It's not immediately obvious, but what you have to do is think of it as a triangle. Side A is the y distance, side B is the x distance, and side C is this diagonal distance that we want to find. Alright, so the x distance, which is equal to side B, -4 to 3, that means B equals 7. Side A, 5 to 1. That means side A is 4. Now we square those, add them together. 49 plus 16 is equal to 65. So 65 equals c squared. C must be square root of 65. Our next theorem is about special right triangles. There are certain rules that allow you to find all the sides of special right triangles, even if you only know one side. That's why they're called special right triangles. The first special right triangle is a 30, 60, 90 triangle, and it's called this because this angle here is 30, this angle here is 60, and this one is a right or 90-degree angle. So it will always have the same ratio of sides. Side A, the shorter leg, will be 1. Side B, the longer leg, will be square root of 3, and the hypotenuse will be equal to 2. So our ratio is 1 to square root of 3 to 2. Our next rule is about the right isosceles triangle. So we have a right angle here, and these sides are equal. So if each of these sides is x, the hypotenuse will simply be x roots of 2. So our ratio is 1 to square root of 2. So here's some example problems. An easier one, here we have a right isosceles triangle. These sides are equal. So we know this side. Can we find the hypotenuse? That's pretty easy because we know that if these two sides right here and here are x, then this will be x roots of 2. So x is 13.7. The answer is 13.7 roots of 2. Next example is with a 30, 60, 90 triangle. So we know the hypotenuse, and from just knowing one side, we can find the two others. First, we find side x. Because side x is 1 when the hypotenuse is 2, it's half of the hypotenuse. Pretty simple. 2.5. Y is equal to square root of 3 when x is equal to 1. So that means that y is x roots of 3, which means 2.5 roots of 3. So our final and simplest concept is the sum of angles in a triangle. Pretty simple. All the angles in a triangle together will always add up to 180 degrees. So angle A plus angle B plus angle C will always equal 180 degrees. It works on every triangle, no matter what. So some example problems for that. First, we know two angles of a triangle. Can we find the third one? That's pretty simple because we just have to subtract the 2 from 180. So 180 minus 97 minus 70 equals 13. So this question mark angle must be 13 degrees because that's what's left over when we subtract these from 180. Alright, this problem down here is a little more difficult. So we know that this angle and this angle are 55 degrees. Can we find this one and fill in all the angles of this triangle here? Alright, so first off, we know that angle M is 55 degrees because these lines are parallel. And we have a rule that says alternate interior angles are always equal if the lines are parallel. But there is no alternate interior for angle L. So how are we going to find it? The sum of angles in a triangle. We know that these two are 55, so we simply subtract two 55s from 180. So L equals 180 minus 55 minus 55, and that's 70 degrees. Alright, that's the end of this video. Thanks for watching, and remember, these are very useful concepts that can help you both in everyday life and, of course, in math class.